Welcome to qnawire.
Outside temperature over a day can be modeled as a sinusoidal function. Suppose you know that the high temperature of 87 occurs at 3 p.m. So if we were to think of a sketch here where let's see, if we have our baseline, our midline, and we know that the high is 87 and the average is 80, that means our low would be 7 degrees below, or 73. And if the high occurs at 3, let's just say then this is 3. In a 24-hour cycle, then every 6 hours will be another critical point. So if 3 is the high, then we're back to the middle at 9. Also 6 hours less than 3, which would be at, let's do it this way. 3 p.m. is, in like military time, is 15. And then this would be at 21. Every 6, so that'd be at 9. This would be at 3, and this would be at -3. So 11 a.m. is what we want to find to the nearest degree. Well, let's come up with a model here. So if we place the axes here, then we recognize that for our equation, the amplitude is 7, the period is 24, the phase shift would be, we got to go 3 to the left, so -3, and our midline is at y equals 80. So our equation would be y equals, that is a negative sign function that I am writing here, so it'd be -7 sine. The period is normally 2 pi, but if it's 24, we gotta scale by pi over 12 times, I'll use x plus 3 to take it back 3, and then plus 80. So let's graph to make sure we got this correct. -7 sine of pi over 12 x plus 3 plus 80. We at least want to see through, I'll say 30 hours. That'll give us the full 24-hour cycle, and we need to see at least up to, I'll go to 100. All right, so we can see that the maximum occurs at 15, which corresponds to 3 p.m. The question is, what would it be at 11 a.m.? And so if we just graph x equals 11, because that would be 11 a.m., we can see to the nearest degree would be 84 degrees.